morning, grade 12 Mindsetters. It is a Saturday, 9 o'clock is your time, and I am Looney. We're here for maths for you guys today. Joining me in studio is Tamlin. Tamlin, how are you doing?
Hi, Looney. I'm fine. How are you?
I'm great, thanks.
Good.
So what are we doing for the grade 12 today?
Today we're having a look at functions, which is always a really big part of our paper one, as well as some calculus.
All right. Grade 12s, you heard it. We'll be here to help you throughout the next probably hour and a half. Remember, we do have Curio on Mixit. It's our new app. So what you guys need to do, we do have the information on our Facebook page. Go register there. Make sure you know everything that you have, because we've got 5 questions that we need you guys to answer. And then throughout the show, Tamlin will be going through the questions, and then the ones that you're getting wrong, she'll be helping you with the questions throughout the show. Remember, you can also download the show notes for today on learnextra.co.za/live. I will post them on Facebook as well. Our Facebook page is facebook.com/learnextra. Remember, on Twitter, our handle is @learnextra. Join me, guys. Ask me any questions that you may have. We are here for you on this beautiful Saturday morning. So let's take away time.
Thank you so much. Yes, grade 12, definitely go and have a look at those Curio questions. There are some good, really good questions that are going to get your brains going this morning. Just to clarify with the Curio, guys, read the question carefully, because more than one answer can possibly be correct. So it's not a typical multiple choice where it's just one correct answer. There may be more than one. So just to clarify that for you before you go and actually have a look at those questions. Right, so let's put that aside for a moment and let's start having a look at some functions. I know that this is a section which a lot of you need a lot of extra practice in, so we're going to spend some time having a good close look at those. Okay. We're having a look at some past paper questions, and this is one that was from one of our previous 2009 papers. Okay. What we've got over here, grade 12s, is they've given us 2 graphs. They've given us the f of x, which is our x minus p squared plus q, which by now we recognize is our quadratic equation. And we've got g of x, which is our equation of a over x minus b plus c, which we recognize is our hyperbola. Okay. So what they've told me is the point A, which is the coordinate of 2.5 and 0, is a point on the graph of f. Okay, that's on our quadratic equation. And P is the turning point of f. The asymptotes, remember asymptotes, as far as your hyperbola goes, is key in terms of the shape of your graph. Okay, so the asymptotes are represented by those 2 dotted lines. And the other thing they've told me, which is obviously important, is that it passes through the origin. So at that point over there, your hyperbola is passing through the point 0, 0. Okay. Right, so let's have a look at what they're asking us to do. So the first thing they're wanting me to do is to determine the equation of g, right? G being the hyperbola. So let's start with the standard equation, because that's always a good place to start, which is our a over x minus p plus q. Okay, now the first thing that's always easy to spot with these is your asymptotes. I've got a vertical asymptote passing through my x-axis at 1, and I've got a horizontal asymptote passing through your y-axis at 2. So the p and the q, grade 12s, are the asymptotes. So let's fill that in. I've got y is equal to a over x. And let's just do this so it's clear. And I'm going to have minus 1 as my x, as the p value, which represents the x asymptote, and plus 2 as the as the value that represents the y asymptote. Okay, so I've got the p and the q sorted out. We know what's happening with those. What you do need to now figure out is what's the value of your a, all right? So the route we now have to go is we now have to look carefully at your graph and identify another point that your graph is passing through, okay? So let's see. We've got our hyperbola. I don't have any points over there. There's nothing concrete I can work with on that side. However, we were clearly told that it was passing through the origin. And as I've already mentioned, your origin is always the coordinates of 0, 0. Okay, so what we're going to do is take the 0, 0, and we're going to substitute it into the x and the y of our equation. So let's have a look. I'm going to substitute y with 0. I'm going to substitute x with 0, and we've still got the negative 1 and the plus 2, and that's going to leave us with what? I'm going to have to work down here, guys. I've got 0 is equal to, I've got negative a plus 2, A is going to move over, and it's going to be equal to 2. Okay, so let's write it on the side here. So g of x, that's my hyperbola, is the equation of, my A was 2 over x minus 1 plus 2. Just a quick thing I'd like to just confirm with you, or something you can use to just double check that you are on the right track, is look at the quadrants in which the hyperbola is sitting. Because if it is in the two positive quadrants, we can see that it's in my first quadrant and my third quadrant. And if it's in your first and your third quadrants, remember that this 2 over here would have to be positive. And so that just confirms that we're right. It should be positive. It's in my first and my third quadrants. We're happy that that all works. Okay, there's nothing there that looks strange or out of place. Okay, let's have a look at the next thing they're asking us to do. Determine the coordinates of P, which is the turning point of F. Okay, let's take this working out the way so we don't bump into that. And let's see what we've got here. Right, P is this point over here. Right, what do we know about the coordinate points at this point? What do we know about the graph F at this point? All I know is it's in the equation of x minus p squared plus q. So let's have a look. We've got y is equal to a. I've got x minus p squared plus q. Okay. Do I have a point that it passes through? Do we know the coordinate points? Okay, we've got a, which is the coordinate points of a 5 over 2 and 0. And we're going to have to substitute that into our coordinate, into our x and our y. And we're going to have to solve for a. We're going to have to solve for p. Okay. Do we have our x-intercepts? Let's substitute in. I've got 0, which is equal to a, x minus p squared. And sorry, x is going to be 0. Let's just erase that quickly. And we've got plus q. Okay. Right, guys, what else do we know? Let's just see here. We know that it's passing through. Okay, what we do know is I've got an x coordinate at my turning point. It's passing through 1. So I've got 1, but I don't know what the y coordinate is. So we don't know that over there. So what we can do is let's substitute. Remember that this point over here, the p, represents the x coordinate of your turning point. So we're going to substitute that with 1. What other points do we have here, guys? Let's see. We're going to have to substitute something. We've got 0 is equal to a multiplied by 1. That's now going to be a minus 1 squared plus q. And what are we doing here? Okay. Guys, what I'm going to do is I'm going to have a look at that in a minute. Let's just see. Looney, are there any Facebook questions just yet?
Not yet. We don't have any.
Okay. Let's just have a look at some chat to the learners.
Come. Well, guys, for now, all you can do is go onto Curio. Remember, we have those 5 questions that we need you guys to answer. So in order for you to join us in studio, answer those 5 questions, guys. And remember, Tamlin will help us answer the ones that you get wrong. So join us on Curio. It is our new Mixit app, guys. So go on to Mixit. I did post all the information that you need on our Facebook page. So go to Curio, answer those 5 questions, and then we'll take a very short break, and we'll see you straight after this, guys. Welcome back, Mindsetters. I hope you guys are ready to go again with our maths. I'd just like to send a shout out to Selo Arthur and Gabelo Khadebe who've tuned in to watch the show. So good for you guys, and make sure you answer those 5 questions on Curio. Tamlin?
Right, thanks, Looney. Okay, guys, I'm actually going to start that question over again, and let's just start with actually the equation that was given to us for f of x. Okay, that's obviously an important starting point. They told me that the equation was y is equal to x minus p squared plus q. Now, based on what they've given me, we in fact actually know what a is, which is something which is sitting in front of us. It's a little invisible 1, okay? So we don't needing to solve for a over here, and we can go ahead and just substitute in what we know, all right? So what we did know was that point A, let me just put up the diagram again. Point A, which is over there, is actually an x-intercept. So we've got the 5 over 2 and the 0. And we knew that the p coordinate of my turning point was 1, okay? So we can substitute that into the p of our equation. So y is going to get substituted with 0. X is getting substituted with x over 5 over 2. P we knew was 1. And we've got q to then solve for. Okay, so I hope that that makes sense to everybody. If I take 5 over 2 minus 1, that's going to leave me with 3 over 2, which needs to be squared. Okay, we're going to land up then with a 9 over a 4 plus q. And obviously that's going to move over to be 9 over 4, which is equal to q. So what was the question asking? It was determine the coordinates of p, which is the turning point of graph f. The x coordinate was 1, and the y coordinate is negative 9 over 4, which is the same as negative 2 and a quarter. Let's just double check it. There's negative 2 sitting over there. So it would make sense that negative 2 and a quarter would be ever so slightly lower than that. So once again, it works. And it's always good to go back to your diagram, grade 12s, and just verify that what it is that you have found does make sense according to the diagram. All right, let's have a look at the next question. Write down the equation of the asymptotes of g of x minus 1. Now, if I've got g of x minus 1, that is telling us that we have got a horizontal shift, okay? It's a horizontal shift of your axis minus 1 unit. The axis has moved back 1 unit. It essentially then makes it look like the points on your graph have moved forward 1 unit, okay? So a horizontal shift of x minus 1 means my asymptotes are going to look like they've actually jumped forward 1 unit. So if my current asymptotes are at positive 1 and through 2 on my y-axis, what would happen if my axis moved back 1 is that I would have my asymptote now looking like it's passing through 2. Let's just, whoops. Okay, let's just move that slightly over. That looks a bit better. So it would be passing through there. As far as the y-axis goes, nothing has happened in terms of a vertical up or down shift. So that's going to stay as it is. It's just the x asymptote that has moved. Okay, so what would the new equations of the asymptotes be? My x asymptote is now going to be x equals 2. The y asymptote is still y equals 2. Okay, so we've got those two equations over there. All right. Finally, write down the equation of h if h is the image of f reflected in the x-axis. Okay, let's give ourselves some space over here. When we are reflecting a graph about the x-axis, grade 12s, we need to just remember our rules of transformations here. If I'm reflecting about the x-axis, it's the coordinates of your y values that are going to change sign. If I reflect about the x-axis, it's the y coordinates that change sign. If it's the y-axis, the x coordinates change sign. So those are rules that by now we should all be quite familiar with and quite easily able to apply. Our f of x function, let's just quickly write the equation down. Our f of x was x minus 1 squared plus, and we had 9 over 4. That was what we worked out our equation to be, okay? So what we're doing is we are reflecting it about the x-axis, which simply means that the y-coordinate is going to, or the y-value is going to have a change in sign. So if this over here represents y, we essentially have now got negative y, which is equal to x minus 1 squared plus 9 over 4. Okay, now with the graph, we never leave y negative. So what I'm now going to do is I'm going to move the negative over to the other side. So leaving us with an equation of y is equal to negative x minus 1 squared minus 9 over 4. All right? And let's see, would that make sense? If I took this graph and I reflected it about the x-axis, yes, that would be absolutely perfect. Okay, so there we go. That's our first function that we've had a look at. We've got a couple more to have a look at now. So let's move on to our next question. All right, so what we've got over here is just a relatively straightforward exponential function, okay? They've told us that the graph of h of x is equal to a to the power of x. Remember, whenever x is in the exponent form over there, we know it's an exponential graph. And a, which is the coordinate of negative 1 and a half, is a point on the graph. Okay, so let's get going and see what they want us to do over here. Explain why the coordinates of Q, so here's Q over here, explain why the coordinates of Q is 0 and 1. Okay, well, let's see. The first thing I can see about point Q is that it's on my y, it's where the graph crosses your y-axis, so it's a y-intercept, okay? And the second we have a y-intercept, we would always say let x equal 0, all right? So if we let x equal 0, then what are we going to have in my equation? We would have h of x, which is equal to a, and it's no longer to the x, it's a to the 0. Now, with exponential laws, anything to the power of 0 is 1, all right? So therefore, what we would land up with is a y equals 1. So therefore, this point over here, where x is 0, y is 1. Okay, so why is it the coordinates of 0 and 1? Because it's an x, it's the y-intercept, and at the y-intercept we let x equal 0, and any exponent raised to the power of 0 is 1. Okay, so that would be why that coordinate came about. Right, now they're asking us to calculate the value of a. So let's see what we've got here. We had h of x, which was equal to a to the x. So that's the equation that we are working with. All right, and we've got points that we are going to have to substitute in. That's going to have to be our first thing to do over here. So let's take point A and let's substitute -1 into the x and 1/2 into the y. So if I've got 1/2, which is equal to a to the -1, how can we now work with that? Well, if I'm raising something to the -1, what I could do to get rid of -1, I could raise it to the -1, because -1 times -1 makes +1. But what happens to one side of an equation must happen to the other side. So anything to the power of a negative would then invert the fraction, so I would land up with 2 being equal to a. So what is the equation of my h of x graph? I've got y is equal to 2 to the power of x. Okay. What you'll notice with this particular equation, grade 12, is that the asymptote of your exponential graph is over here at y equals 0. Okay. So in our equation, just to point it out, I don't have any plus or minus value behind your a to the x because the asymptote is 0. If there was a plus or a minus behind it, it's implying that there's a vertical shift, either up or down, and that would obviously change whatever your asymptote was, okay? But just to bring your attention to the fact that the asymptote is y equals 0. All right, so a was equal to 2. That's what we have just worked out, okay? Write down the equation for the inverse function of h to the -1 in the form of y equals. All right, guys, let's give ourselves some space over here. We've got an h of x equation, which is 2 to the x, which means that y is equal to 2 to the x. Now, as soon as we're trying to work a function that is an inverse, so that's our notation, we would write it as h to the -1. As soon as you're looking for your inverse, we are looking for, and for those of you who are busy with your curio questions, this might be useful to you. Anything that's an inverse, you are reflecting it about the line y equals x. Okay, that's your inverse. And how do we do that in terms of actually working it out? We take the x and the y coordinates and we swap them. Okay, we swap them around. So where there was an x, we replace it with y and vice versa. So that's what I'm going to do. To work out my h to the -1 equation, I'm going to say x equals 2 to the y. So if you look carefully, you can see what I've done is I took the x and the y's and I swapped them, all right? But it's not good enough to just leave it like that because any function is in the form of y equals. So y needs to be the subject of the equation. So what I now need to do is rearrange this to get y as the subject. So in order to do that, and I'm sure you guys are sitting, if you've learned logs, we know how to approach this. We are going to change that from exponential form to log form. Okay, we're going to say y is equal to log base 2 to the x. And that's the equation of the inverse of h. Anytime you're taking the inverse of an exponential graph, you are going to get a log graph. Okay. Okay, so let's write it over here. So we had y was equal to log base 2x. Okay, now they're wanting us to sketch a graph of h to the negative 1, and we're going to indicate this on the graph with the coordinates of 2 points that lie on this graph. Okay, that's going to be quite easy, actually. What I'm going to do is just tidy this up slightly so that it is not too... Okay, this point over here was 0 and 1, and that point over there was negative 1.5. So let's quickly do this. A's point, when it's reflected about the line y equals x, what we do again, if we've got the line y equals x, let's just draw the line in here so you know what we're talking about when we talk about the line y equals x. That's it over there. And we always label it y equals x. All right. We swap the x and the y coordinates around. So if I've got this point A over here and I'm trying to work out its reflection about the line y equals x, I swap them around and it becomes a half and negative 1. And if I took Q and I found the reflected point, it's going to be 1 and 0. So let's now plot that. If I've got 1, which let's estimate is around about there, okay, then a half is going to be, so that's going to be a half. And negative 1, I'm going to have to estimate, I'm putting it over there. So this over here is now the reflected point Q, and no, that was A actually, sorry. That's A. And the reflected point of Q is 1 and 0, which is going to be this point over here, that's Q. All right, so what our function is going to look like is it's going to go through there, and it's going to go through there, and it's going to approach your asymptotes. Remember, it never ever crosses it, so it will never actually cross the line of x equals 0 now, because that would be the asymptote of your log graph. Okay. All right, guys, so that's what the picture of your log graph will look like, which is the inverse of your exponential. Right, moving on to the next question. We now want to know, read off from your graph the values of x for which log base 2x is greater than negative 1. Okay, so I'm looking for, so let's start with this. Let's draw a line where I've got negative 1 as a y value. So that's where y is equal to negative 1, all right? And basically what we wanted to know is, where is my graph greater than x equals negative 1? It's greater than over here. All right? So therefore, looking on our x-axis, at this point over here, this was where x was equal to a half. So my solution on my axis is going to be everything where x is greater than a half. So I'm going to say that x is an element from a half, and I'm using a round bracket because we just said greater than, we didn't say greater than or equal to, and it would then go off to infinity. So that would be the values for which your log base 2x function is greater than negative 1. All right. And finally, they want us to do this calculation over here. They're saying that if g of x, now remember g of x we've already worked out is 2 to the power of x. If g of x is equal to 100 times 3 to the power of x, determine the value for x for which h of x is equal to g of x. All right, so let's see what we're going to do. H of x was our original function. That's this one over here. G of x is equal to this 100 times 3 to the x. So I'm going to make them equal to each other. Like so. Okay. Right, now we need to solve this, okay? So if I need to solve it for x, the first thing I need to do is make sure that everything that's got an x is on one side of the equation. So the first thing I need to do is, instead of multiplying by 3 to the x on the right-hand side, I'm going to divide it by 3 to the x on the left-hand side. So it's going to look like so. And we will get rid of it on that side. So therefore, this is what we've got. I've got 2 to the x over 3 to the x is now equal to 100. So let's rather write this as 2 over 3 all to the power of x, which is equal to 100. Now, what we're sitting with here is an exponential equation where the bases of the equation are not the same, okay? So I can't use the typical route of solving an exponential equation. We are going to have to use the logarithmic route, okay? We're going to have to actually change this into log form. The way we change it to log form is I make x the subject of the equation. So I say x is equal to, I've got log base 2 over 3 to 100. And in this case over here, we're going to have to use our calculator. So let's see what we've got. I've got log. Let's clear that for a second. I've got log base 2. Where's my base 2? Okay, this one doesn't seem to want to bring up my base 2. As it is over there, it's bringing up a base 10, and that's not going to help me so much. You guys can do this, though, however. You can actually put that in your calculators. Just type in your log base 2 over 3 to the 100. Work out your answer. You will more than likely, in your instructions, be told to what decimal places you need to round off to. So just make sure that you type that in and get your X answer in terms of decimal places. All right, guys, I think we're going to take a short break. We are going to continue with more functions when we get back. And don't forget your curio questions. Make sure you go and have a look at them because a lot of them apply to exactly what we're talking about today.
All right, guys, we are going to take a very short break. Remember those 5 curio questions as Tamlin reminded you. Answer them, guys, and all those that you don't know and you got wrong, Tamlin will help you with them. Remember to post all your questions on Facebook. I see some of you guys are asking a lot of questions. I will ask Tamlin during the break, and then we'll answer them right after this. So don't go away, Mindsetters.
Hey, calling all you grade 11 Mindsetters. In case you missed out on any of this week's lessons, catch us here this Sunday from 9 until 6 p.m. for extra maths, physical sciences, life sciences, or maths lit. Here on Mindset Learn Extra. Learn more, learn extra.
Welcome back, Mindsetters. I'm so glad that you guys are tuned in and you're ready with us. You're asking many questions about this topic that we're doing. So Tamlin Pindulo Zohan is asking, I'm really enjoying this maths revision, but on this hx is equal to a to the power of x graph, I'm lost on the part when you raise -1 to a. That's question 1.2.
Okay, I think the question that we're referring to, I'll just close that for now, was the previous question where we had, no, it wasn't here, it was this one, where we raised it to the -1. Okay, over here. All right. Basically, this is what the story was. We had, I must now just recall what it was that I was doing here. Yes, we had we substituted in the point. Okay, that was what we were doing. We substituted in the point A, which was x was -1 and y was a half. Okay, so what I did there was that a half went into the y and -1 went into the x. So what you were sitting with was a to the -1, which was equal to a half, okay? Now, you want a on its own, so you need to somehow devise a plan to get rid of that -1 that's sitting up as an exponent. And a useful way to do it is by raising it to the power of another -1. And the reason why I do that is because when I raise a power to a power, they multiply. And a -1 times by a -1 is going to make it +1. But any rule of equations will tell you what you did to the one side of your equation must then be done to the other. So I raised the other side, which was a half, to -1, all right? Now, rules of exponents. If you're raising something to the power of a negative, if you've got a fraction which you're raising to the power of a negative, by inverting the fraction, it changes the negative to positive, all right? So by taking 1 over 2 and inverting it and changing it to 2 over 1, it then made that negative exponent positive. So that was really just talking about rules of exponents, which if you're having a problem with that, go back to your grade 10 and 11 notes and just revise your rules of exponents, because it can be a bit of a problem if you're stuck on that and you're not sure where to go from there. So that would be my advice. Go back and do a bit of revision on exponents work there, and I'm sure you'll figure that one out quite quickly. All right, I know there was another question on Facebook just regarding the axis of symmetry of a hyperbola. And it's actually quite a good question, so I'm going to elaborate on that very quickly. If you've got a hyperbola, and I'm going to just draw myself one over here quickly just as an example. Okay, let's use our nice pink axes here. Okay, let's say we have got just a normal hyperbola where the x and the y asymptotes are 0 and 0. So my hyperbola looks like so. All right. Your axis of symmetry is going to be the line y equals x. It's going to pass straight through the middle over there, and y equals negative x is in fact the other axis of symmetry. It passes through those 2 points. So an unshifted graph would have the equation of y is equal to positive or negative x as far as the axis of symmetry goes. If there's any shift that takes place, okay, so let's take these out, and let's see if we can. No, that's not going to work. Okay, I'm going to move it up. Now let's do another picture. Okay, I'm going to add in a new axis of symmetry. I'm going to put an asymptote through there, and I'm going to put an asymptote through there, and I'm just going to say for now that that's 1 and that's 2, let's say. Okay, so that means that the point at which the two asymptotes met was actually at the point of 1 and 2, all right? So if I now wanted to know the equation of the axis of symmetry through that point over there, what we're going to start off by saying is that the axis of symmetry is a straight line. So it's got to be in the form of y equals mx plus c. Okay? The gradient of 1. This line over here had a gradient of 1. And as it moves up or down, that gradient is not changing. So the m, the gradient of your axis of symmetry, is going to stay constant. That's going to stay 1. All right, so that will be 1x plus c. But I now am not passing through 0, 0 anymore. I'm passing through the point 1, 2. So you would substitute y with 2, and you would substitute x with 1, and you'll work out that we get 2 minus 1, which is 1, which is your c value. So then y is equal to 1x plus 1, which would be the equation. Okay, so that's just a quick guide on how to work out the axis of symmetry of your hyperbola if it's actually been shifted. If it hasn't been shifted, y equals x is the solution you're looking for. If it has, you keep the gradient the same. That doesn't change, but it does matter as to where it passes through, where your x and your y asymptotes cross each other. Right, guys, so I hope that that answers the questions that we had. And let's see if we can move on to the next question over here. Okay, this time we've been given an f of x function, which is a quadratic function. I've got negative x squared plus 7x plus 8. And I've got a linear g of x function, negative 3x plus 24. So there's the picture of the two graphs. And a pretty typical question that they would normally kind of throw in as a first question is calculate the coordinates of a and b, which are both your x-intercepts. So guys, remember, and this doesn't just apply to a parabola, it applies to any function. If you are looking for the x-intercepts, you let y equal 0, okay? So we are going to take our f of x equation, and we're going to let y equal 0. So I've got negative x squared plus 7x plus 8. And I'm going to now get rid of the negative. We can divide by negative, which makes it minus 7x minus 8. And we factorize. Okay, and we've got x and x. Factors of 8, which will give us 7, are going to be 8 and 1. 8 is minus and 1 is plus. So what have we got as our two x-intercepts? I've got x is equal to 8 and x is equal to negative 1. Just be aware of how they asked the question. They did say the coordinates. Okay, so we make sure we write the coordinates. A is going to have to be the negative 1 and 0 x-intercept, and B is going to have to be the 8 and 0 intercept. Okay, so there we go. We've got, sorry, that's positive 8 and negative 1. There we go. All right, so those are the two x-intercepts over there. And those are the coordinates. Right, now we're going to calculate A, which is the x-coordinate of D. All right, so here we go. This is point D over here, and A is the x-coordinate of that point. So what we're needing to now do is try and find a way to work out what is the value of that A, okay? And the starting point that we're going to have a look at is, what is point D? Okay, let's have a look and see. It's not an x and a y intercept, that's for sure, but what it is the point where the two graphs intersect each other. It's where they cross, okay? So what we could do is work out algebraically what are the coordinates of the point where the graphs intersect? How would we do that? How do we work out the points of intersection? Well, what I would do is I would take my f of x function and I would make it equal to my g of x function. All right? And we would solve it algebraically. So let's see, f of x was negative x squared plus 7x plus 8. Negative x squared plus 7x plus 8. And we are setting that equal to our g of x, which was negative 3x plus 24. Negative 3x plus 24. All right, so now I've made the two equations equal to each other. The reason, guys, is because it's a point of intersection, and at a point of intersection, your functions are equal at that point. Okay, so now that we've done that, we now need to solve the equation. So let's gather all x's to the left. In fact, we're going to gather everything to the left, and we're going to make the right-hand side equal to 0. Right, and it's equal to 0. Okay, what I'm now going to just tidy up, add some like terms together. I've got a 7x plus a 3x, which is giving us 10x. I've got an 8 minus a 24, which is going to give us minus 16, and it's equal to 0. And I'm going to divide through by a negative, which means I'm going to get positive x squared minus 10x and plus 16 equals 0, and now what we need to do is factorize it. Okay, so we've got x is equal to, or x and x. Factors of 16 to get us to 10, I'm going to have to use my 8 and my 2, both of which are negative. So we're getting two x coordinates here. X is equal to 8 and x is equal to 2. Now here's something quite interesting. We already know that this point B over here is 8, and that is also a point of intersection. So that point 8 belongs at point B, which means that the other x coordinate I worked out, which was 2, is going to have to belong at D. So at D, my x coordinate is 2, which is going to answer the question that they were asking because they wanted to know what was the value of A, which was the x coordinate. So the answer we've got there, guys, is that A was equal to 2. If we wanted you to go further and we wanted you to actually calculate the value of B, what I would have to do is take my x equals 2, and you just have to substitute it. Now you can sub it back into either f of x or g of x. It's your choice. I would suggest the one that involves a little less working out. So possibly sub it into g of x, and you'll get your coordinates quite easily. Okay, I hope that that's all understood. Right, now, this is a very common question, guys, and something which I really suggest you take careful note of, because in terms of calculus and functions, it comes up quite a lot, so just pay attention over here. They're telling us that point S, which I'll go back to the diagram in a second, is a point on the graph of f where A, which we now know, let's cross out A and say 2, because we now know that that's 2. So x is essentially between 2 and 8. And the line ST is drawn parallel to the y-axis with t on graph G, and determine ST in terms of x. Okay, so putting that into plain language, let's see what they're asking us. They are saying that between that point over there and between that point over there, so that's why they identified the value of x being between 2 and 8, okay, between those 2 points over there, what they're saying is that this line from S to T is a line between those 2 points, okay? And it's a line between the two graphs. So what they're asking me to do is they're asking me to determine an equation that represents the line from S to T, okay? Now this is going to be a good starting point. The second you have to work out a vertical line that is between your two graphs. You are going to start by saying, in this case the line is called ST, so we're going to call it ST. And I'm going to take my top graph, which in this case was the parabola, and I'm going to minus the bottom graph from it, which in this case was the straight line. Okay, so that's what we need to do. So we're going to take the equation for ST, and we're going to say negative x squared plus 7x plus 8, that was the equation of the parabola, and we're going to subtract, I'm just going to erase some of this here so we don't get confused, right? And we're going to subtract the equation of the straight line graph, which was just negative 3x plus 24. So negative 3x plus 24. Okay. And now, obviously, this is not too difficult to do. We're just going to simplify. We've got negative x squared. I've got 7x. Okay, I'm going to do a bit of working out just in my head over here. That's a plus 3x, so we're going to have positive 10x. And I've got positive 8 minus 24, which was negative 16. Okay, so that equation represents the length from S to T, all right? That's what it is. And now the question is, what can we do with that? The following question underneath that question, so now we've established this is what we had, so let's just write here. ST was equal to x squared plus 10x minus 16, hey? Minus 16. All right, that was the equation. Now a follow on from that. Calculate the maximum length of ST. All right, so the idea here is that this length of ST is not a fixed point. It can move all the way, anywhere between the 2 points of intersection. So point ST can be anywhere in between in that space, okay? And the question is essentially asking then, if it were to move between the 2 points of intersection, at what point would it be at its longest, okay? So what we need to then do is work out at what point it would be at its longest. And I'm sure at this point, for those, we've all probably done calculus by this stage, is that calculus is going to jump to mind the second we see the word maximum. Okay, we're allowed to use our rules of calculus over here. We're going to apply our rules of derivative. I'm going to find the derivative of ST. And I am going to let that derivative equal 0, because that's what we do to find a maximum or a minimum. Okay, so let's see. The derivative of ST is going to be dst over dx is going to be, right, 2x plus 10 represents the derivative. I'm taking it from here. So that's the derivative of st, and we are letting it equal 0. So let's just get rid of all that green writing there. So we're letting it equal 0. So therefore, 2x plus 10 is equal to 0, okay? Which means that 2x is equal to negative 10 and x is equal to negative 5, all right? Does that work in terms of my graph? Have I made a, possibly I've got a sign mistake somewhere here. It looks like it should be positive 5. I think it was negative x squared, that's the problem. Let's just double check. Yeah, okay, there we go. So it was actually negative x squared, so that's supposed to be negative 2x, sorry, and there's negative and negative, so it becomes positive, right? So for which value of x is the length from s to t at its maximum length? In this case, it's where x is equal to 5, okay? Guys, go and look in your past exam papers. Look for that question. It's there a lot, okay? And if you know what it's asking, it's actually quite a simple way of calculating it. It's just knowing what it's asking, okay? So go and find those questions, go and practice them. Definitely worth enough marks to justify the work, okay? Right, Looney, are we in for a break yet?
Yes, we are. Mindset says we're going to take a very short break, but I am trying to post all these questions that Tamlin is doing on our Facebook page, so you guys have the actual graphs. You can look at the actual graphs and you have all the questions. So I'm trying my best to upload as she's going along, but then we're going to take a short break, but do remember to stay tuned and we'll be back right after this. Hey grade 12, Saturdays on Mindset are exclusively for you. Join us this coming Saturday for lessons in maths, maths lit, physical sciences, life sciences, business studies, geography, and accounting. Don't miss out. Welcome back, Mindsetters, from that very short break. Remember, guys, we have asked you to answer those 5 questions on Curio. All you need to do is go into Curio, answer the questions, and remember to press the submit button. That is the only way that we'll be able to see if your answers are right or wrong. So remember, when you're done with all 5 questions, press the submit button so that your answers can be valid and can be checked if they're right or wrong. And then straight after that, Tamlin will check all the wrong questions that you've got problems with, and we'll work through them during the show. So Tamlin, let's take it straight back to you.
Great. Thank you, guys. Right, so what we're going to have a look at now is a bit of calculus, okay? So we've had a look at functions, and as I mentioned before the break, make sure you practice them, guys. Once you've done enough of them, it does start becoming the questions become quite expected in terms of what comes up. So definitely put time into those. Right, calculus. The first question that's very typical in terms of a calculus paper is that they ask us to find the derivative by means of first principles. Before we get going with that, I think a good place to start is let's just define a derivative. What is it what are we doing when we're calculating a derivative? If by now, grade 12s, you've worked through calculus and you're still struggling to grasp what is this derivative, make sure you always hang on to the definition that a derivative is calculating the rate of change at a point. Okay, so you're working out the gradient of a tangent at one particular point, and the rate of change at a point is another way of phrasing that. Okay, so that's what we are doing in terms of working out a derivative. Okay, now this method of first principles is just a way of working out your derivative, and it's the way you would have learned right in the beginning when we taught you how to find derivatives, okay? But it's important to know because obviously in your exams you will definitely be asked to do one of them, and they're worth a lot of marks, okay? So these are marks in the bag as long as we know the method, okay? Right, the method being, let's start with the formula. We've got our f prime x, which is equal to our limit, where h is tending towards 0, where f of x plus h minus f of x all over h, excuse me, is our formula. Okay. Right, so let's see what we've got over here. This is my f of x formula. So let's write next to it what f of x plus h is going to be. F of x plus h is going to be exactly what you've got over here, except that where you have an x, you're going to replace it with x plus h. So where I have an x, I've got an x plus h squared minus 2, and where I had an x, I'm replacing it with x plus h. Okay, so into our formula, we are going to say equals limit. Remember, we keep our limit right up until the end. Right, f of x plus h is x plus h squared minus 2 times x plus h minus the original f of x function, which was this one over here. So minus, in brackets, x squared minus 2x. And this is all over, we're going to use a nice straight line here, that's all over the LCD or the denominator at this point, which is just h. Okay, equals limit h tending towards 0. What have we got now? Now we just have to tidy up. Okay, so some careful foiling out here. We've got x squared, I've got plus 2xh, I've got h squared. Distribute negative 2, so we've got negative 2x, I've got negative 2h, minus x squared plus 2x, and again, it is all still over h. Okay, all still over h. All right, equals limits h tending towards 0. And now let's tidy up. Now, a very worthwhile thing to know at this step, grade 12s, is that anything that doesn't have an h in it needs to cancel out, okay? So if you've cancelled out and you're still sitting with values that still have an x in it with no h's, go back and check your working out because somewhere in there there's an error, okay? So you just got to watch out for it. So x squared minus x squared cancels out. Minus 2x plus 2x cancels out. Let's just double check what I've just said. That's got an h in it, so I'm happy with that. That's got an h, and that's got an h. Okay, so everything that I'm left with does have an h in it in each of the terms. Okay, so therefore we've got 2xh plus h squared minus 2h, and it's all over h still. Now, the reason why it's important for everything to have an h in it is that in order to actually go forward with this, I need to take out h as a common factor, which means I'm going to be left with 2x plus h minus 2, and it's all over h. So they cancel, and the reason why that's useful is because now I substitute my limit into my sum, and you cannot have naught in the denominator. So that's why you've got to get rid of that naught that's in the denominator. So we take naught and we substitute it into our sum, and it's at this point, grade 12, that we no longer write limit, we just state equals to. And it's equal to 2x plus naught, that's the h, minus 2, and we get 2x minus 2. And that is the derivative. Okay, so let's just double check for ourselves. Let's make sure we write here. Remember, the shortcut rule for derivative is as follows. If I've got f prime x equals, remember the rule is we take our 2 and we multiply it in front, so I've got 2x, and I take 1 and I multiply it in front, so I would have minus 2. Let's just get rid of that for now. I would have minus 2, and that x would fall away. So 2x minus 2 is finding the derivative using the shortcut, but I'm just confirming that, yes, that is actually the correct answer. So what's really nice about first principles is that you can check your answer, and you can make sure if you are correct. And as I say, get that method right, and it's nice marks in the bag, okay? Right, now that we've done first principles, so that's that part done, now they will typically ask you to find the derivative using your rules of differentiation, okay? So we're not going to actually go through that whole process of first principles. We're just going to now apply the shortcut rules. So we're going to take 2 examples and show you how that is done. But before I start with the examples, let's just talk about a few things that need to be remembered. When we are applying our rules of differentiation, first of all, there may not be any surds. Okay, so if you've got a square root in any form, please make sure that you get rid of it by writing it in exponential form. All right? Very quickly, as an example, if I've got the cube root of x to the 5, how would I write that? It would be x to the 5 over 3. Okay, so that's what I mean regarding that. And the other thing, remember, is that if you're finding the derivative in terms of x, there may not be any x's in the denominator. So if there were any x's in the denominator, let's say, for instance, something like that, or let's make that 2, then what I would do is I would write it in the numerator, and I would write it as x to the negative 2. So that's very important to remember. And finally, multiply all your brackets out. Okay, you can't find the derivative until all your brackets are multiplied out. Okay, guys, so please remember that, because that's important. You can't find the derivative until you've dealt with all of those points. All right, so let's take my first example over here. They're asking us to calculate d of x, where x cubed minus 3 is being squared. Okay, right, in terms of the notation over here, excuse me, d of x is going to stay. With this notation, it is telling us to calculate the derivative in terms of x. So we keep our d of x until the point that we actually do calculate the derivative, and then we just state equals, all right? So d of x stays where it is, and what I'm first of all going to do is times out my brackets. I'm going to do FOIL, and that's going to give me x to the 6. I'm going to get negative 6x cubed, and I'm going to get plus 9. And once I've done that, I have no surds, I have no x's in the denominators, so now I can go ahead and find my derivative, so therefore I write just equals. And the rules, we multiply x in front, so I have x, 6x, and remember we subtract 1 from the exponent, so I've got 6x to the 5. 3 times 6 is negative 18, and it's x squared, and any constant term where there is no x falls away. All right, so the derivative of our first sum is going to be just 6x to the 5 minus 18x squared. Okay, right, easy enough. Let's have a look at another one. This one's a little bit more tricky because we've got a few surds and a few fractions involved. So they're telling us that y is equal to 4 over root x minus x cubed over 9. Okay, so based on what they've told us, we are going to find the derivative. Before I can do anything, that's a problem because, first of all, it's a surd, and secondly, it's in the denominator. So I definitely need to sort that out. And while I'm sorting it out, I'm not finding the derivative. So please watch your notation here, grade 12s. I'm not finding the derivative yet. So in that case, my notation is still just y equals. We're not writing dy over dx yet. Okay, so y equals, we're going to write this as 4 over, as an exponent, that's going to be x to the half minus x cubed over 9. And I'm still not happy. I still can't find the derivative yet, so I'm leaving it as y equals, and I'm going to bring my x to the half up to the top. So it's going to be x to the negative a half minus x cubed. And is it okay to leave a constant term such as 9 in the denominator? That's fine. I don't have a problem with that, as long as it's not an x. Okay. All right, so we've taken care of the problems in terms of we can't find the derivative just yet. We've sorted all of that out. Now we can find the derivative. So now is the case we change our notation to dy over dx, calculating the derivative of y in terms of x, and we multiply. So 4 multiplied by negative a half is going to be negative 2, and if I subtract 1, I'm going to land up with negative 3 over 2. I'm going to multiply forward, so I've got negative 3, that's going to be x squared, and this is over 9. So just tidying up and simplifying a little bit, let's see what we've got. So my derivative is as follows. It's going to be negative 2. I don't like the negative exponent, so now I'm going to bring that down to the bottom to write positive 3 over 2. And 3 will cancel with 9 3 times, so we've got x squared over 3. Okay. And finally, what's normally expected of us is that if we've got an exponent that's as a fraction, we should write that back in third form. So negative 2 is going to stay as it is. I've got the square root of x cubed, and I've got x squared over 3. All right. And there we go, grade 12s. That is then as far as we can go regarding that. That's finding the derivative, and we're done. That's the answer we're looking for. Again, not to repeat myself, but go and practice them, please. This is something that, again, requires a lot of practice. So go and find as many examples as you can and really just drum that method in, because it's important to understand that. All right. Have we got any other calculus questions before we move on to that one? No, we don't. Okay, right. This is now a great question. With your calculus, remember, once you have found derivatives, once you've done first principles and even graphs, which we haven't really done here, but hopefully we have some time to throw one in at the end, we have our maximum minimum question, okay, the ones where we have to calculate the maximum area or the minimum volume or whatever it is that they're asking us to do. So let's have a look at what we've got over here. These require a little bit of out-the-box thinking, guys. You need to just be able to apply your knowledge, all right? Nothing here is something you don't know. It's simply a case of applying what we know. All right, so first piece of advice, read your question very carefully, all right? We have got a piece of wire, which is 4 meters long, is cut into 2 pieces. One is bent into the shape of a square, and the other into the shape of a circle. Right, okay, so if the length of wire used to make the circle is x meters, write in terms of x the length of the sides of the square in meters. Okay, right, so let's have a look at what we've actually got here. Let's make it quite literal. We've got a piece of wire. That's what they told me. And they told me that the piece of wire was 4 meters long. Okay, so we know that. Now they said to us that they've cut this wire into 2 pieces. So let's chop the piece of wire into 2 pieces. And they said that the one piece is bent into the shape of a circle, which they said was x meters. So the piece that's being bent into a circle, that's going to be x meters. And what was left is being bent into the shape of a square. Now what's left, grade 12s, would obviously have to be the total 4 meters minus the x that we've taken away. So 4 minus x represents the length that we're using for the square. All right, so let's see what they're asking me here. Write in terms of x the length of the sides of the square. Okay, so let's give ourselves some space here. So we took this piece of wire, which we've now established was 4 minus x meters. Oh, so am I writing there? Okay, and we bent it into the shape of a square. So if the perimeter of your piece of your square was 4 minus x, to calculate just one side, I would obviously have to take the 4 minus x and I would have to divide it by the 4 sides of your square, okay? To work out, let's call these S over here, to work out the side of your square. So therefore, one side of your square is going to be 4 over 4, which is 1 minus x over 4. All right, so that is the length of just one side of your square. 1 minus x over 4. So that's the answer here. Side equals 1 plus, no, let's remember 1 minus x over 4. Okay. Right, that done. Now let's see what they're asking us. Show that the sum of the areas. Ooh, okay, so we're going to have to work out the area of the square and the area of the circle, and we're going to have to add them together because that's what they're asking for the sum of. So we're taking the area of the two shapes, and they're asking us to prove that it gives us this equation over here. So guys, a few things. This over here is really your safety net. Okay, that's saying that's the answer that we want you to get to. Are you allowed to use that in any way to actually prove your sum? No. Okay, you're not allowed to do that. So just watch out. If they're telling you to prove an equation, they're telling you that that's the answer you want to get to, but you're not allowed to touch that. Okay, that's got to be there as a checkpoint at the end. Okay, so just watch out for that. All right, so let's now put this all into practice. Right, let's start with the square. To work out the area of this square, I'm going to have to take length times breadth, which is going to be 1 minus x over 4 squared. Okay, so if I square that out, I'm going to get 1 minus, if I take x over 4 minus another x over 4, I'm going to get minus 2x over 4. I'll simplify it in a second. And plus x squared over 16. All right, so that's that foiled out. That's the area. In fact, we can simplify it ever so slightly. We can say x over 2 plus x squared over 16. And again, that just represents the area of your square. Now let's talk about the area of your circle. Okay, the circle we haven't really spoken about yet, so there's a few things we need to know. All right? The circle said that the perimeter, or the circumference of your circle was x. That's what we were told in the very beginning. The length of x was bent to make the circle. So, what the perimeter, and remember the perimeter of a circle is 2 pi r. That's equal to x. So what's going to be useful over here, guys, is that I need to know what, in terms of x, is the radius. Okay, and that's what I'm doing over here. I'm going to get r on its own, which means that your radius is the length of x over 2 pi. Okay, so that's x over 2 pi. Okay, so let's just confirm what I've done over here. So they told me in the beginning that x was the length of the piece of wire that was bent into a circle. So the perimeter of that circle was x, okay? So I used that information. I said, okay, well, if the perimeter is x, then 2 pi r would have to be equal to x. And the reason that was useful to me is because I need to find r in terms of x. Now, where is that going to come in handy? Because I now need to work out the area of the circle. And the area of a circle is pi r squared, okay? So pi times by the radius, which I now know is x over 2 pi, is being squared. Okay, and let's just simplify that. So I've got pi, that's going to be x squared, and that's going to be 4 pi squared. Okay, that pi can cancel with one of those, so I'm left with x squared over 4 pi, and that represents the area of the circle. Right, lots of calculations, but let's just recap what we've done. So we've found the area of the square now. I've found the area of my circle. And the sum was asking me to add them together. So that's the next step I need to do over here. So let's make sure we've got everything we need. I need to take this over here, the area of my square, and I'm going to add it. So let's just write that down. 1 minus x over 2 plus x squared over 16. 1 minus x over 2 plus x squared over 16. And I'm going to add the area of the circle. Let's call this our total area. We're going to add x squared over 4 pi to it. Okay. Now let's see what I can do over here. I've got an x squared and an x squared. So what I'm going to do is I'm going to rearrange this slightly. I'm going to take out an x squared as a common factor between these two terms. which is going to leave me with a 1 over 16 plus 1 over 4 pi. And what I'm then left with is a negative x over 2 and a plus 1. So I've got x squared bracket 1 over 16 plus 1 over 4 pi minus x over 2 plus 1. Let's just double check what they were wanting us to get. And if you have a close look, it's exactly what they were wanting us to get to. Okay, so quite a lot of complicated working out over there, but if you're just careful, there's nothing there that you shouldn't know. It's just a case of, again, applying that knowledge. Okay, we're next going to find the maximum value of it, but I'm sure it's time for everyone to take a short breather before we do that. So I think let's have a short break, and I'll finish this off when we come back.
All right. Guys, I'm enjoying reading all your posts and all the questions that you have. I do ask Tamlin during the break, so don't sweat it. I will go through all your questions. Remember to answer those 5 questions on Curio, and remember, it only will give you your answers if they're right or wrong once you press the submit button and once you've answered all 5 questions. So do that during the break, and we'll see you straight after this. Welcome back, Mindsetters. We're in our last segment. I hope you guys have been enjoying maths. Tamlin has been taking us through some revision questions, so I hope you guys have been enjoying that. So I'll take it straight back to Tamlin.
Super, right. We just need to finish this question off. Okay, so typically now they've asked us to find this equation that represents, in this case, the area of the 2 shapes. And now what they're wanting us to do is, and if you have a look at the question, it states, go back through them, how should the wire be cut so that the sum of the areas of the circle and the square is a minimum? All right, so they want to know exactly where should they actually cut those 2 pieces of in what ratio so that we land up with a minimum area. In calculus, guys, the second the word minimum or maximum come up, what we are doing is calculating the local maximum minimum, which means we're looking for the derivative equals 0. Okay? So that's what we need to do with it. So we need to take the derivative of our total area. Let's do it in pink. The derivative of our total area in terms of x. Okay, that's what we're trying to find. Okay, let's see if we can work this out. The derivative of this is going to be 2x multiplied by 1 over 16 plus 1 over pi, 4 pi, minus the 1's going to jump to the front here. We're going to land up with just 1 over 2, and the 1 will fall away because remember that doesn't have an x on it. Okay, so let's just distribute here. I'm going to land up with 2x over 16, which is going to work out to be x over 8. 2x over 4 pi is going to land up with x over 2 pi and minus a half, and we're letting that derivative equal 0. Okay. In this case over here, what I would suggest now doing is finding a lowest common denominator. Okay, we want to find an LCD, which is going to have to be an 8 pi. All right. So what I'm going to have to do is multiply this over here by just pi. Here we're going to have to multiply by 4, and we're going to have to multiply by 4 pi in the third one. So we're going to have pi x plus 4x minus 4 pi, and it's equal to 0, all right? And you can drop your denominator now, because you can, when you're working with an equation, once you found an LCD, you can drop the denominator. And let's see now, I'm going to bring this 4 pi over to the side because it doesn't have an x on it. So we've got 4 pi, which is equal to, and the next thing I'm going to do is take out x as a common factor, leaving us then with pi plus 4. So 4 pi over pi plus 4 is going to be the answer in terms of pi. However, if we're actually looking for the value, we would type it into our calculator. So let's see if we can work out what that's going to be. For those of you very quickly, in fact, I actually took it up on the calculator earlier. This particular log question, if you want to page back a few just in that log question when it wasn't coming up, that's the answer that you should have got for that value of x when we were looking at that log. So just wanted to bring your attention to that. So let's just clear the calculator. We're going to work out. So I've got 4 pi. 4 pi over, and I've got pi plus 4, and we're getting a 1.7. Let's round it off to 2 decimal places. So a 1.76 as the answer for x there. So 1.76 meters, 1.76 meters should be the length of your circle, and 4 minus 1.76 meters should then be the length for your square. And that would then give us the minimum area if we added them both together. All right, guys, so again, lots of practice. You need to make sure that you have seen enough of those, that you're comfortable enough with them to actually go through all of that working out, because there's a lot of working out there. But with practice, you do become more comfortable at it, and it becomes easier to work through. So there we go, lots of practice. Right, guys, I think time has come to have a look at those curio questions. There were some very worthwhile questions there regarding our functions and relations and whether things were inverses or not. So let's have a look. Luni, have we had a good response to our questions?
Well, I think so.
Okay, I've got a couple. Okay, what I've got over here is the sort of detailed breakdown on what it is that we've had over here. So let's have a look. Question 1 was asking us to select all the mappings that described a function. We didn't have too many people get those right, okay? We had enough people getting right which of the following functions have asymptotes. And the 4th question, okay, we had some people get those right. So I think let's maybe have a look at, let's quickly close that. Let's see if we can answer, okay. Right, let's have a look at the first one and see if we can actually go through these. The question asked you, select all the mappings that describe a function, all right? Well, remember with a function, guys, the way we define a function is that for every x value, there is only one y value. Now, there's a couple of different ways in which that can actually be conceptualized. You can either have a 1-to-1 function, so one x value has one y value, and that's that. We could have many x values, which are all attached to one y value. That's still a function, because every x value, although there are many of them, are still only attached to one y value. So that's still a function. When there's a problem is where I have one x value attached to many y values. That is then not a function. So for the first one, one to many. So one for A, I think that was supposed to be many to one. Many to one, yes, is a function. So the first answer was correct. One to many, guys, that is not a function. Watch out there. You've got to just think about it carefully. 1x to many y's is not a function. 1 to 1, yes, that's a function. 1x to 1y. And many to many, well, no, that's definitely not a function. So anything where one x value is associated to, well, an x is associated to one y value, it is a function. 1 to 1 or many to 1, that's what you're looking for as far as a function goes. Right, so the answer there, guys, was A and C. All right. Let's see what the next question was talking about. Which statements about functions and inverses are correct? Okay, so let's go through these over here. Right, the inverse of any function is formed across line y equals 0. No, that is not correct. An inverse is y equals x. That's the line it's reflected about. The inverse of 2x plus 2 is linear with a gradient of a half and a y-intercept of -1. Well, you need to go work that out. To work out the inverse, you swap the x and the y around and you solve for y, okay? And when you do that, you should actually find that no, that is not correct. You should be getting a gradient of, or is it right, sorry? A gradient of, if I'm not mistaken, sorry, that's right. It's a half and -1. Okay, so yes, that one was correct. If you did that calculation, you would have seen that one was perfect. The inverse of x to the half is x to the power of 2 is y to the power y equals x to the power of a half. Yes, that one was also true. So those ones were correct. So in this case, B and C are correct. And the reason why D is not correct is because, yes, log base 2 to the x is the inverse of 2 to the power of x. That part is correct. But then it went and said that it's not a function, and that's not true. A log graph is a function. And so that's why that final option was actually an incorrect option. So there, B and C were the ones that you were looking for. All right. Okay, you guys seem to have a fairly good idea on the asymptotes. And unfortunately, I would love to go through the cubic graph with you guys, but unfortunately, we're out of time. So what I'm going to suggest you do, we've gone through calculus. with all the practicing that I've already told you have to go and do, I want to throw in that you need to go do cubic graphs on those as well, because obviously that's part of your functions as well. Guys, it's been an awesome lesson. I hope you've learned lots, and I look forward to seeing you again. And until then, work hard.
Grade 12, it's been great. Thank you so much for tuning in. Remember, you can still continue with the questions on Curio. It hasn't stopped, guys, so you can still continue. Coming up next, though, we do have physical sciences. So we'll see you next time, grade 12s. Goodbye.